Okay, welcome to the homework on proofs. This is the tough one. We're going to cover proofs for the rest of the semester. This is not your first pass. You've seen it before when we first did Fitch, but now this is the real stuff. So this is your first pass at really how to do proofs on your own. When we first started off, all we had, if you remember, was anacon and equals elim, which was substitution, and that didn't get us very far. I said later on, when we did proofs there, I said just follow the reasoning step by step, and that's good enough. If you can't solve it on your own, that's fine. I'll teach you that later, and that's what we're starting for the first time here, how to construct this stuff from scratch. And it builds upon the connectives, and in fact, it builds upon the truth tables, what we just did previously. So I want you, this is the lecture right here. I want you to read it through as always. And also open up on the side the strategies and rules sheet that I have in La Lima. This is really important. It's worth your time to get to know this. It's basically, in essence, how to solve proofs, but it's difficult to read and apply, and it requires a lot of practice. That essentially is what proofs are, just practice and logic in general. So it's worth your time to print this thing out, and whenever you work proofs, have it on the side and be able to sort of follow it through. The reason for that also is I will print this out and you will have access to it on the midterm and the final. You can't bring your own. It'll be provided for you at the exams. So exactly as it is here. So it's worth your time to read it through, okay? So let's go through the lecture first, and then I'll work a bunch of problems, and then I have a bunch of video links and audio files to help you out through this rather difficult homework. It really does require perseverance, and you're not going to get it even with several passes. The first, we're going to work one homework here, and then we have a second one for the next homework set. It's just proofs, and you're going to feel very sort of uncomfortable with it, and that's natural, and that's the way it normally works. We're going to put it on the side, move on to new things, and then we'll come back to proofs, and that's where it needs to start to gel in preparation for the midterm. Okay, so here we go. Remember, proofs are an unbreakable chain of rules, unbreakable chain of inferences, and what makes them unbreakable is the use of rules. And when we first started off, we had anacon and equals elim, which was substitution. Now we have new rules corresponding with the three connectives that we've been introduced to, not, and, or. Okay? Open up again the rules and strategies sheet, print it out. It's worth having it on the side whenever you work proofs. Let me take you through each of the rules first. Okay, so for the AND rules, it builds off the truth table. If you think about it, AND is only true with both sides true. Yeah? So if you're given an AND statement, whatever it is, it means, say, A and B, right? Or right here, the example I gave, I went to the game G and I had a beer B. So AND elim basically tells you if you're given the statement G and B, and is true only when both sides are true, you can break off either side of the and. You can break off the G, I went to the game. You can break off the B, I had beer. The point is, since you know and is true only when both sides are true, each of the sides must be true. Okay? So if you want to see this formally, what I've explained in words, go to the rule sheet. The first page is about basically how to solve proofs. Don't worry about that for now. We'll come back to it. That's the hard page to read. And then after that, I have a library of all the rules in there. So the first page is how do you solve proofs, and it tells you to look up rules. And after that, in the remaining pages, is a library of all the rules. So here's the and rules right here. Let's start off with what I started off before, and elim. So I have it right here. Yeah, the second one in the and section. The and rules right here, second one. So the form of and elim, according to what I said, I go to the game and I have beer, but it doesn't matter. It's any form of this and that. So let's just call it L and R. L stands for anything, R stands for anything. And we'll denote that I have L and R for just left side and right side. And is only true when both sides are true. That allows you to break off either side. So since both sides are true, I could break off R. Or if I wanted, I could break off L. Either one. I have R here, but it could have been L. What I have in the boxed areas here, that's basically the essence of what the rule says. So you can read this as a way to understand what these forms are saying. That's why they're called formal rules. There's a pattern to them, a form to them. Yeah. You can read this right here. I've got the same thing as what I just said. Okay, let's go back to the lecture now. For the and rules, I also talked about, I didn't talk about this yet, but I said there's a symmetry to them. There's something called an elim rule and an intro rule. We talked about this previously. Don't worry about why it's called that. Just think there's always a symmetry. For any connective, there's always an intro and elim rule. We just covered and elim. Intro is the reverse of elim. It says if you're given the component pieces, you can put them together to form a composite. So and elim is basically breaking off. If you can think of this as a given and statement, whatever it is, you can break off either side. Introduction, by contrast, is making. Think of intro as like a if you're making the example I always use, if you got a Reese's peanut butter cup and you want to make that, you want to bake it or whatever, however it's made, you need the component ingredients. So if P here stands for chocolate, and Q stands for, or better yet, P stands for peanut butter, Q stands for chocolate, I need each of the components separately. I then stick them together to form P and Q. Yeah, that's and intro. In terms of the truth table, you can think if I know P is separately true and then Q is separately true, that must mean putting them together P and Q is true because I have both the components true. So all of these are sort of extensions of the truth table of everything we did before, but they're formalizing it into these patterns of these rules. Okay, so that's the and rules. Let's move on now to the or rules. This is also in the lecture, and you can read it through what I have right here and correlate that with the rule sheet if you want. I'm just gonna go over this in words right here. I'll go straight to the rule sheet. So let's cover or intro first because this is the easier rule. Or intro says if you have one of the sides of the or above, then you can say that side or anything, or the reverse, anything or P. The order doesn't matter. What's the logic of that? The logic of it is, think of the truth table. When is or true? Or is true when at least one of the sides is true. So whatever your side is, P, or, and the other side doesn't matter. If you just got one of the sides above true, so if I know P is true, does it follow that P or whatever else is true? Yes. Why? Because or is true when at least one of the sides is true. So the way or intro works is you need one of the component sides of the or, the left side or the right side. In this case, I just have it in that order, but it could have been reversed. Somewhere up above, and that'll make the or true. Okay? We'll practice this. This is all abstract right now. When we practice it and practice it some more, it begins to make a little bit more sense. You can always think these correspond to the truth tables and what you know about them. Alright, or elim. This is the tough one. This is the one that'll cause you problems, and it's the toughest rule for the midterm. It's abstract. It's got a lot involved, but it's also, it turns out, one of the most powerful of forms. Why that is, I'll explain later. So or elim is informally called proof by cases. Okay, let me use an example here. Oh, well, before I do that, let me go over its form and then use an example. So you're given P or Q. In 427 last time, the reason why we did that was to sort of prepare you for, and if you remember my audio lecture, I went over this. 427 is basically to prepare you for this or elim rule. If you didn't quite get it then, that's okay, but it was really just sort of prepping your mind for encountering this rather abstract and difficult rule. So if you're given an or statement above, P or Q, think about it. For or, when is or true? When at least one of the sides is true. Do you know for sure P is true? No. Do you know for sure the other side, Q, is true? No. You just know at least one of the sides is true, maybe both, but you just don't know which of the sides exactly is true. So what I have here, if you look at it, this first thing that's in the boxing I'll explain later. The boxing is basically the highlights. Don't pay attention to that for right now. But within this second box, I have what's called a sub-proof. An overall proof is this first line, and usually there's premises at the top, and within that I have a further proof, which is called a sub-proof. A proof, what it says in English, a Fitch bar just says, assuming this stuff on the top, this other stuff follows. So a sub-proof just says, suppose furthermore, this on the top, and then show that this thing on the bottom follows, okay? So how does this work? What is it saying in English? Well, it says, look, since we don't know for sure P is true and we don't know for sure Q is true, we just know at least one is true, maybe both, but we don't know which one. This first subproof says, let's suppose for the moment, just suppose for the moment, P were the one that's true. Have that here. Dot dot dot. I don't have that here, but dot 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 means you go through some reasoning. You arrive at some sentence S. S is anything, just abstractly some sentence S. Okay, stop there. The second subproof then corresponds to the other option. You got two options, P or Q. Again, you don't know which of the two is true, so you have to explore each one. So you say, now suppose on the other side, Q is the thing that was true. Not P, but Q. Let's suppose for the moment. Dot dot dot, I arrive also at the exact same sentence S, whatever it is. So whether P is actually true or Q is actually true, which I do not know, in either case I arrive at that same common denominator S that allows me then to extract safely the conclusion S because they're in common with both, even though I don't know for sure whether P or Q is true. Okay, that's abstract, that's a lot. Let's make this concrete. I covered this in the audio lecture as well. So you got a murder that's committed, right? And if you're a good investigator, what do they say? You leave no stone unturned. So you got Philip or Quincy as the murderer, P or Q. Suppose Philip is this nice elderly gentleman in his 90s, everyone loves him, and there's no way you look at him that he committed the murder. But if you're a good investigator, you don't know, right? Maybe he's the mastermind behind it all. I mean, there's a number of these shows that you guys have seen where the person who seems gentle and whatnot is actually the one who's the mafioso boss behind it all, right? So anyway, here we go. Suppose for the Philip or Quincy committed the murder. We don't know, maybe one, at least one did it, maybe both did it together, but we don't know exactly who did it. So what Ori-Lim is getting at, what this proof by cases is saying is explore each case and drive to the same common conclusion, okay? So suppose for the moment Philip is the murderer, right? You have access somewhere outside of this to other evidence. So, and that's the stuff going on here in between the dot dot dot. Okay. So looking at other evidence, I know according to the forensic evidence that the murderer must have been right-handed because the skull was impacted in such a way that the force required the natural hand to be used. So let's suppose the murderer is right-handed, right? So that's my conclusion here, S. And then I say now on the other side, Q. Suppose Quincy committed the murder. Dot dot dot. I go through some reasoning. Same thing, right? Well, I look at the forensic evidence, so the murderer must have been right-handed, so S. So in either case, whether Philip committed the murder or Quincy committed the murderer must be right-handed. From that, you can then go on to claim other things. That's independently of this rule. You might say, okay, now let's look at Philip or Quincy and who actually, what their hand, is one right-handed or is one left-handed? Can we eliminate one? That kind of thing is extra to this, but the point is this sort of fits that general pattern. If that doesn't quite work with you, doesn't make sense to you, let's try one more example to sort of help make sense of this. This is cheating slightly because it's actually guilty of what's called a fallacy, which we'll cover at the end of the course. Fallacies are mistakes in reasoning. Part of what we do in logic is study two sides of the same coin. One, what are good reasoning practices? What has to follow and what not? That's the sort of lifting weights to the mind, structuring your mind, sort of like you lift weights, you structure your body. The flip side of this is what are the common mistakes made in reasoning? After you get sort of this weightlifting of mind, you then apply it in other forms of fallacies or mistakes made. Fallacies is one of many other kinds of studies of logic. We only have time to sort of sample that at the end of the course. But anyway, so this is guilty of a fallacy, keep that in mind, but it works as a good example. Suppose you got someone on the stand, you got two lawyers going at it, and this person is on the being prosecuted, and they're accused of beating their wives, right? Their wife. And so the guy asks what's called a loaded question. That's the fallacy. But he says, did you stop beating your wife? I want you to answer just P or Q. Yes or no. My P is in this case yes, or Q. In this case, the Q is no. Just answer yes or no. Suppose the person on the stand is smart. Whether he committed this crime or not is separate, right? But for the moment, he's thinking, what do I answer? So I either answer yes or no. Suppose, that's the P. Suppose I answer yes. Well, if yes, did you stop beating your wife? Yes. That means, if you think about it, at one point he was a wife beater. S. Damned. So your S in this case is you're damned. You're going to jail. Okay? So he says, no, I don't want that. So he goes, okay, let's try the other option, Q. In this case, Q is no. So no. Did you stop beating your wife? No. You mean it's still going on? Jerk. Right? Okay, you're going to jail again. So S. In either case, whether he answers yes or no, in either case, damned. S. He's going to jail. So that's sort of the pattern of Ori-Lim. It fits this general pattern of the reasoning, and it applies to any number of things, whatever your P and Q are. Okay, that's the end of the rule sheet for right now. The other rules, the not rules, I'll cover that later. What I want to do right now is go to the first home, which is basic 6.2, which is basically practice with these basic rules, okay? So 6.2 is practice with the rules. 6.3, you should read this through and try it out. It's better to read it through and listen to the audio file for sort of slow digestion as always. But I'll have a video that I'll do right now with 6.2. 6.3, I actually have a video of that already. So this takes you through the backwards method, and it uses the rule sheet. So it both covers this first page. Forget this stuff up here. It covers this starting off first, the backwards method. And it goes through some of the other things as well. And then 6.5, so 6.3 has a video. You should check that out. 6.5 is a tough one. In fact, it's the toughest of this whole homework package. I have lots of guidance for that, and then most importantly, you can check out the video if you want visual guidance for that. And then I cover the knot rules after that. For the knot rules, for those problems, I have videos and guidance for that. But after this video right here for 6.2, I will briefly cover the knot rules, and then I'll leave you to those other materials to use. Okay? So let's go on now to 6.2. I'm going to close the lecture here. And then 6.2 says, open up the file, exercise file 6.2. In general, files, Fitch exercise files, remember, do not create them from scratch. What I mean by that is do not open them up from scratch and then start entering everything in. All these things are in the Fitch exercise file, so be sure to open it from there. It'll save you a lot of grief in general. So here's 6.2 in there. If it'll open up. Okay, there we go. That was slow. Let me, oops, no, not that. Let me darken the lines, make things bold, make it a little larger so you can see better. Okay. So if you remember from when we first did proofs, the first thing was you cut and paste this at the bottom. That's already done for you. And then that whole algorithm for how to set up the proofs, right? That still holds here. But the difference is in this problem, they've already pretty much done it for you. That last step, if you remember, the most important step was you go to proof and you do show step numbers. Make sure you do that. So I got the numbers shown there. Let me hide the goal strip. We don't need that. Okay, so here it is. Here's your first proof, and they've already, if you notice, got a bunch of rules filled in. They did a lot of this for you. You need to fill it in because really this is just about, even though it's ugly and long, don't worry about that. We're just trying to understand how the rules apply to these things, this whole thing, step by step. This is just step by step together. This is just step by step. Okay, so let's start at the bottom. And in general, you always start at the bottom. I'll explain that later, the backwards method and all that kind of stuff. But they give you a rule here, or elim. They tell you or elim is what you need. So or elim has this pattern. There's an or up top. You got the two subproofs and the matching S at the bottom of there, and there. The bottom of each subproof and at there. That's the or elim, okay? So in this case, what we have to do is get this to check up. When I check it right there, it's going to give me the X because I haven't basically met the pattern as it occurs here, yeah? So let's put that on the side so you can see it. Okay. So what I need first off, if you look at this rule right here, the first thing that needs to be highlighted, that's what the boxes are, the highlights. The highlights are the same exact things as numbers, okay? Over here I can't put numbers because you don't know what numbers are. So in general the highlights mean numbers. So since I put numbers down, the first thing highlighted, where this all comes from, is the or as the main connected. The first sentence is the only thing you got access to at 12. The rule for axis, if you remember from when we first did proofs, was anything above, right? Wherever you're at. So if this is the pointer, you only have access to stuff above. But now there's a new amendment to that axis rule. It's above and to the left. So 12, if you look, 2 through 5 and 6 through 11, they're to the right of this line that you're on. Anything to the right, you do not have direct access, again, to stuff above axis, again, to stuff above and or to the left. So if I go up 12, The only thing I really have access to is 1. 1, the main connective is OR. Why is it the main connective? It's outside of parentheses. That's what gets highlighted. That's what gets boxed. So I put the 1 there. The second two things, if you look at the rule here on the left, the second two things that need to be boxed are the two subproofs. One starting with your first case, P, and ending in S, and the second one starting in the other case, Q, and ending in S. In this case, my P happens to be the same P, right? So here's my first subproof, 2 through 5. It starts with P and it doesn't end in S. So I highlight that, but the problem is it doesn't have the S there at 5, so that's a problem. And then the second subproof is the other side of the OR, which is Q and R. So that's here at 6, Q and R. And then it's got to end in S, and there it is at 11. How do I know what my S is? Remember, S is any sentence. It's always identified by your OR elim. Whatever your OR elim is at, that corresponding over is the S. So in this case, my S is this long P or Q and P or R. So if I check it the way I have it now, I have the highlights in the right place, but it gives me the X because I'm missing that last component, the S. So I go to 5, I fill it in, I cut and paste that in. Now I check it, and go back to 12. You have to move your pointer back down to 12 to check it. And then there I get the green check. I have all this laid out in this boxed area in my rule sheet. Right here, what I have in bold, the 3 things you need. The 2 subproofs. At the top of each are each of the sides of the OR, and at the bottom of each of the subproofs is the same S. You fulfill that along with the highlighting, and you got yourself a check. This stuff is difficult because unless you get everything down, that's what makes it formal proofs. They're structured and rigid in that way. You will not be able to move on. So once you get the check, and only when you get the check can you move up, go on. Whenever you get a check, you move up. So in this case, I'll move to 11. Now, I don't have a rule here, but they give me 2 highlights. What is the main connective for 11? The main connective is AND. So let's think back to the true table. When is AND true? Only when both sides are true. Well, what are my sides here of the AND? One side is P or Q, and the other side is P or R. I have at 8 P or Q, one of the sides listed there. What do I need at 10? In order to put this together, I need the other component. So you have to type this in from your keyboard, capital P or capital R. I go back down, I check it, it will not give me the check yet. What rule fits that pattern? Well, let's go up. It's one of the AND rules. What AND rule says, if I'm given the component pieces, if I'm given the peanut butter and the chocolate, I can then make the Reese's. That's, if you think about it, and intro. And that's exactly what this pattern is here. So I click on rule, I go to intro and it gives me, when I check it, the check. Okay? Only when you get the check then can you move up. Now I move up to 10 or intro. They give you that rule here, but it's not going to give you the check because nothing is highlighted. So if you look, now let's look back to the rule sheet, or intro. What did or intro say? It said I needed one of the sides above to get this to check, or above to get this to check out. Okay? That's what this area right here says. These are all the keys to understanding the rules. This area on your right that's boxed in your rule sheet. So going back down here, what are my sides of the OR? P is one side, R is the other side. Do I see one of the sides above? Well, remember, you have access to anything above and to the left. So at 10, I'm on this line right now, I have access to 9, 8, 7, 6. You see this gap right here? You can't jump over it like some video game. You fall through the space to the left and 1. So what you have access to at 10 is 9, 8, 7, 6, fall to the left, 1. You don't have access to 2 through 5, okay? So OR intro is there. I need one of the sides of the OR above. Do I see exactly one of the sides, the P by itself or R by itself? Yes, at 9. If R were true, then I can say R or whatever. So that gives me the check there. Now I move up to 9. 9 is what's called simple, meaning there's no connectives. It's just R by itself. Okay, how am I going to get R by itself? Well, this is again where you ask, what do I have access to? The rule again is above and to the left. So at 9 I have access to 8, 7, 6, fall to the left, 1. Do you see R anywhere there? Not in 8, not in 7. It is in 6, and it's also in 1. But 1 is already being used in this nasty OR elim, so probably you're not going to use it again. So where else do you see R? In 6. What does 6 say? Q and R. What's the main connective? AND. When is AND true? According to the truth table, it's only true when both sides are true. That must mean each of the components are true. That must mean R already has to be true. So it follows what rule. Now the question is, what rule fits that pattern? So go to the rule sheet. What says if you're given an AND above, you can break off either side, the left and right side? That's this one right here, and elim. So that fits right here. I'm breaking off the right side, the R, to get R there. That's and elim. I go to elim and I check it, and now it's good. Okay, continuing on, I move up to 8 now. I need a rule here, and they give me nothing to highlight, so I'm on my own on this one. What's the main connective? OR is the main connective. When is OR true? When at least one of the sides is true. So my sides here are P and Q separately. Do I have one of the sides above? Yes. Where? At 7. So I highlight 7. The question now is, what rule fits that pattern? If you remember, OR intro says you need one of the sides of the OR above. And this fits that pattern. So we can choose the rule OR. Did I say OR elim? I meant OR intro. We can choose OR intro because we have one of the sides. We are introducing the OR. We are making the OR because we have the Q above, and that checks out. Okay, now 7. They give you a rule here, but nothing to highlight. So and elim is what they've chosen here. Let's go to the rule. What does and elim say? And elim says if you're given an and above, you can break off either side of the and. So in this case, where's my and above? Well, at 7, I only have access to 6, fall to the left, 1. 1 is not an and statement. 1 is an or statement. That's the main connective. So the only and I'm given is indeed, since I have each of the sides, the left side is Q, the right side is R, and I'm breaking off the left side, that works here. You verify it, you're good. Okay? Let's continue on now. Let's move on to the other subproof, 2 through 5, which we haven't done yet. It's very similar to what we did here, but slightly different. So it says here you're given and intro, and if you highlight, oh, that's the nice thing about Fitch. It actually gives you the form of these rules if you need them when you hover over it. But what I have in my sheet is what you should always be using, because you're going to be using that on the midterm, so it's worth getting to know that. This other stuff is just backup. So it says and intro here. What does and intro say? And intro says, if you go to my rule sheet, you need each of the component ingredients to make the Reese's, right? What are my component ingredients here? My left side is P or Q. That's one ingredient. What's the other ingredient? P or R. Do you see exactly those cut and paste forms above? Yes. At 3, there's one ingredient, and at 4, there's the other ingredient. Put them together, and you get that. There's your and intro. Now you move up, 4. This one tells you it's OR intro. What does OR intro say, if you remember from the rule sheet? It says you need one of the sides of the OR above. Okay, what are my sides? P is one side, R is the other. What do I have access to? 3, 2, fall to the left, 1. Do you see P by itself or R by itself somewhere up above? Yes, at 2. So you highlight that, and you get that to check out. You now move up to 3, and now this tells you no rule, but they highlight the P is true. If you know P is true, does it follow that P or Q is true? Yes. Why? Because OR is true when at least one of the sides is true. This is the reverse of the same reasoning we just did at 4. The rule for that is OR intro. You have one of the sides, and there it is. You choose up above. There's 2 buttons. One verifies it step by step. The other one verifies the proof. I recommend choosing verify proof in general, because it just tells you what checks out, where your X's are, and you turn the X's into checks. And there it is right there. There's your completed proof. If you followed it as you did it along with me with your own, you can get that. Or if you want the picture file of this to try on your own, you can. I have that in La Lima. Let me shrink it just a bit if you want to see it. No, I need to shrink it some more. And then hide the gold strip. And there it is. There's the completed proof. Okay, what does this say working what's called top down? Putting this all together. Top down is actually the hardest step in doing proofs, but it actually means the most. But you're not at that stage yet. Hopefully you'll get to that stage when we come back to proofs right before the midterm, when we practice it. But it's hard to get to. Right now we're just doing it step by step, okay? So I want to show conclusion P or Q and P or Q and P or R. I'm given in 1 options. I know that P is true. I don't know for sure which of the 2 is true, whether it's P or Q and R. That's like Remember, Philip committed the murder, or in this case, let's say Quincy and Robert committed the murders, right? So the two subproofs say, let's explore each case. First subproof says, suppose P is true, just for the moment. Well, if P is true, P or Q is true. Why? Because I have one of the sides. And if P is true, likewise P or R is true, because I have one of the sides. Putting them together, 3 and 4, I get P or Q and P or R. That's the end of the first subproof. Now, let's try the other subproof, the other case. The other case was Q and R. So if I got Q and R, that must mean since and is true only when both sides are true, each of the sides is true. So that must mean Q is true, and also at 9, R is true. Well, if I know Q is true, I can get Q or P. Why? Because I have one of the sides of the or. And also, if I know R is true at 9, I can get R or P, because I know one of the sides is true. I have the R. And then putting those together, 8 and 10, I get P or Q and P or R. So whether P is in fact true at 2, or Q and R is in fact true at 6, which we don't know, in either case, we get the same corresponding S at 5 and 11. P or Q and P or R. If that makes some sense, great. That's for elim. Okay, for the rest, 6.2, 5, and so on. Remember, I have, for a lot of these, video guidance to help you through. One thing I want to cover that's not in any of the videos is that's going to come later after. That's going to come later after you do 6.2, 3, and 5. The remainder of the package covers the knot rules. The knot rules are pretty straightforward. Well, the first one is. The second one a little bit more complex, but you guys actually have exposure to this in everyday reasoning. So not elim just says if you're given some sentence with not P, remember the knots, they cancel out. It's like two negatives in mathematics. So not P, not elim, you're actually eliminating the knots to just get P. You're not really going to use this rule that much. It's really only used in conjunction with this one. Not intro is the powerful rule, okay? It's also called proof. It's called indirect proof, reductio ad absurdum, proof by contradiction. And going hand in hand with that, you have also contradiction rules. But let me just cover not intro first. The contradiction rules, I covered that in the audio lecture, and when it shows up in the exercises, I'll cover it there. So right now, I'm just going to cover not intro. Not intro says you assume the opposite, P. You arrive at this symbol right here, which is a contradiction. If your reasoning in between is okay, the only problem that occurs then is in your assumption P, in which case not P is the case. So that's not, you introduce a not intro. Okay? This is how you set it up. You need the subproof, the opposite statement at the top, and the contradiction at the bottom. To illustrate this, suppose, I mean, think of again the law scenario. Somebody wants to get their client accused of committing a crime, right? And you want to show that my client did not commit the crime, so he is commit the crime. So my client did not commit the crime. So you say, let's play devil's advocate. Suppose my client actually did commit the crime, P. Well, if he committed the crime, according, and then I'm going to make this up, this is the reasoning in between. According, if he committed the crime, he must have been there physically present, according to the various forensic evidence at, say, 12 midnight, right? But the problem is, according to numerous eyewitnesses and so forth, my client was in the bar from 6 in the morning until 6 in the following morning, there 24 hours. Since it's physically impossible to be in two places at the same time, that's a contradiction. Therefore, my client did not commit the crime, whatever that crime is. So if that kind of makes sense, good. That's the idea behind not intro. The problem now is setting it up and applying it in proofs. Okay, folks, proofs is a tough one. Keep at it, especially here. We're applying everything that we've done in the past here, especially the truth tables. I have videos and all this other guidance to help you out, so make sure you utilize that to sort of work through this as best you can. The main thing is always get the 2 points from your homework. Remember, if you get the 2 points, that not only is helping you to prepare for the midterm and the finals and so forth, it puts you in the best possible position to sort of, when the light goes on, to get it. And it does require a lot of practice. Some may get it quicker than others. That's just the nature of logic, but it requires lots of practice. But it also is almost an insurance and almost a guarantee that all the homeworks get perfect. Do all the homeworks get perfect points? There's almost no way you can't get through the course. That's the way the course is structured. It is, again, an exercise almost quite literally in fortitude and self-discipline and keeping at it, keep with it.